Notice that the paper is burning down to give ashes because ash has low energy, paper has high energy. The difference in energy is coming out as a heat of reaction or enthalpy of reaction. The enthalpy of reaction is equal to negative because it is coming out. You take an acid reacted with a base. Will there be a reaction?
Yes, sir.
Yes, sir.
If you feel the solution will become hot, yes or no?
Yes, sir.
Yes, sir.
Even this is called neutralization. Here, enthalpy of neutralization is negative. Sometimes you take a rice in a container and put in the container for 5 minutes. Can the food be cooked?
No, sir.
You have to heat it, right?
Yes, sir.
So, rice plus water gives rise to cooked food. It requires heat to be absorbed. Delta H is negative. Yes. You
Yes,
take a pan and put a egg yolk. Will you get omelette?
Yes, sir. Provided if heat is given.
Notice that the egg yolk becoming omelette is a reaction where delta H is positive. It is noticed that simply by placing egg yolk on a plate, you will never get omelette. If you simply start burning a paper, it will completely burn down to give ash. It means this reaction is proceeding by itself. This egg yolk itself is not becoming omelette by itself. It requires external heating, it doesn't require. Once you start the reaction, that's all it's done. So reactions for which delta H is negative are called exothermic. What they are called, sir?
Exothermic.
Oh, they happen by themselves. And reaction for which delta H is positive are called endothermic. Often those reactions happen only if you give a push, like heating or weighting or whatever. Yes, sir?
Yes, sir.
Yes, sir.
When you are burning petrol, heat energy is released. Do you think that all heat energy released you are able to use to run the car?
Sir, once again, please.
In a car, you are burning petrol or diesel. Due to the combustion of petrol or diesel, you get heat energy. Do you think that you are able to use all the heat energy produced to convert it to mileage?
No,
No,
sir.
sir.
Efficiency is always less than 1.
You are using a cooking gas cylinder and you are lighting your stove. Do you think all heat energy produced due to combustion of fuel, are you able to use all the heat energy that came out for cooking?
No, sir.
No, sir.
You know, 70% is wasted. It is wasted as heat energy to surrounding, or a part of the fuel is not burnt, unburnt gas is escaping. Maybe it is escaping through burner or through valve slightly to some extent. Yes, sir. Some heat energy is wasted by the utensil itself to rise its temperature. Hello, sir. So a part of the heat energy is always wasted. How it is wasted, why it is wasted? The amount of heat energy wasted in a process is represented by T delta S. T is the temperature, delta S means causing disturbance in the surrounding or causing indiscipline in the surrounding, or causing disorder in the motion of molecules in the surrounding. It is also called entropy. This is the part of the energy wasted. This is the part of the energy produced. And the difference between these two, produced minus wasted, is equal to what, sir? Hello.
Change in Gibbs free energy.
It is called useful energy. The useful energy is represented by delta G. If you are putting a standard condition of 298 K and 1 atmosphere pressure, under those conditions, the energy released in the process is called standard enthalpy change. So delta G0 is equal to delta H0 minus T delta S. Are we clear?
Yes,
Yes,
sir.
sir.
If you are
Yeah.
carrying out the process at any other temperature, at any other pressure, it is simply enthalpy change minus T delta S, and it is delta G. You know, these equations, auntie and boy, are different.
Yes, sir.
Yes.
For auntie, conditions are standard, for boy, not necessary. Sir, if you want to know the relation between boy and auntie, delta Z is equal to delta Z0 plus 2.303 RT log K. There is a relationship thermodynamic gives, where K is called equilibrium constant. Are we clean about it, sir?
Yes.
Yes, sir.
Sir, fundamentally, what is delta G?
This
Delta G is the useful part of the energy in a process that is carried out at any temperature other than 298 and any pressure other than 1 atmosphere. Yes, sir?
Yes, sir.
Yes, sir.
Ladies and gentlemen, the delta G is found to be equal to minus NFE, where E is called cell potential. In fact, whenever a battery is operated, all the energy produced is really useful, sir. Nothing is wasted, sir. Yes or no? So useful amount of energy produced is given by delta G is equal to minus NFE, where N is the number of moles of electrons in a typical cell like Zn, Zn plus 2, salt bridge Cu plus 2 by Cu. The number of electrons involved in the transfer is 2. F means charge of 1 mole of electron, that is
96500.
96,500 coulombs, and E is the cell potential.
yes.
Ladies and gentlemen, I want you to notice standard Gibbs energy change is equal to minus NFE0.
Hello.
Sir, in a process, you are reacting zinc metal with copper sulfate, aqueous. You are getting zinc sulfate plus copper metal. Here,
Hello,
Zn0
Palan.
is becoming Zn plus 2, copper plus 2 is becoming copper. In this entire process, the enthalpy changes delta H, sir. If you are carrying out the reaction outside, out of this entire energy released, the part of energy that is useful is delta G0 under standard condition. Yes, sir. Therefore, the efficiency of the cell is often described as minus NFE0 by delta H. Any problem, sir?
No, sir.
So actually, I have made a video on this and I have sent you. I don't know whether you have seen it. Have you seen that video?
No, sir.
Mostly no. Because yesterday it got uploaded by 12 o'clock. I was struggling to upload it yesterday. There is power was not good. Anyway, you got what is efficiency of a cell? Hello?
Yes, sir.
Yes.
You all agreed that delta G is equal to delta H minus T delta S.
दिल चुराने मैं आ गया तेरे मुंह से अच्छा तेरी सूरत से अच्छा जो है मेरा बुल्ला है रे तेरी बहन को छोड़ दूं
Congratulations. Somebody is playing wonderful music because everybody is tired today. Therefore, they want to entertain you. So we need to congratulate those people. I have already done that. Thank you. Okay, sir?
Yes.
Now we are looking
Sir,
at
what
delta
is
G.
energy loss, sir?
Excuse me,
In
sir.
Energy loss, sir.
Actually, if you are carrying out the reaction between the zinc metal and copper sulfate in a cup. Delta
मुंह से
H is the heat.
सूरज से अच्छा जो है मेरा बुल्ला है रे तेरी बहन को छोड़ूं तेरी नियम्मा कोगला मड्डा रे नियव्वा माँ के लड़े ఎంత దింగుతావా మీ అమ్మ చెప్పాలా నేను నేనేం ఏం చేసినా
ఏం చేస్తావురా నువ్వు?
अरे बहन के लौड़े आ गया दिल चुराने मैं आ गया
Okay, sir. I'll after the meeting you can't unmute. Is okay, na? Okay, sir. When people don't get along, what they do, they try to cause a kind of disturbance to others. See, a helpless person will try to find fault with others and try to derive pleasure when others get irritated. If you are getting irritated, you are accepting others' nuisance. Because we are not accepting it, we are not getting irritated. Simple. Never ever get irritated, sir. Okay. Now, today my idea is, what is the use of the let us do one thing, let us look at the NCERT. The problem is, if I am writing, somebody is able to overpour the board and create nuisance. So, it is very easy to identify the person who is causing disturbance and remove him, which I don't want. You understand? The problem is, we should give a fair chance for people to mend their ways. Okay. My point here is simply that Nernst equation is useful for finding the delta G value. Delta G is always equal to minus NFE0. Delta G is always equal to minus NFE, and E means cell potential. Cell potential can be calculated using the Nernst equation from the standard cell potential. Standard cell potential is represented by E0. You know, E0 is always equal to E right minus E left. E0 is always equal to electrode potential of cathode minus electrode potential of anode. E right minus E left. We have done problems on that. Always E0 is equal to E right minus E left. Let me show you where it is. The electrode potentials are given in metals like lithium greater than potassium. What is this? The order of ability to act as a reducing agent. Who can act as a reducing agent? Who can lose electrons? Who can lose electrons? Fellow which has lowest SRP. In these elements which has lowest SRP, lithium. So lithium is the better reducing agent than potassium, than calcium, than zinc, than iron, than copper. In fact, copper has positive electrode potential. In fact, copper would never lose electrons. Copper never react with acid to give hydrogen. Always, if you take two electrodes, E right minus E left, the electrode potential of cathode minus electrode potential of anode will give you the cell potential. If you are putting zinc in zinc sulfate, copper in copper sulfate, connect these two using a salt bridge. In the standard Daniel cell, cell potential is equal to E right minus E left. In this, what is right? The electrode copper is right because it has high potential. Which is left? Zinc is left because it has low potential. E right minus E left under standard conditions will give me standard cell potential. Now, sir, if I know standard cell potential, if I change the condition of temperature, pressure, and concentration of solution, the cell potential changes. The change in the cell potential is given by a relation. E cell is equal to standard cell potential minus 2.303 RT by NF into log Q. Q means concentration of product ion by reactant ion. In the cell of zinc copper sulfate gives zinc sulfate and copper. The product ion is zinc ion. The reactant ion is copper ion. Therefore, here the Q represents product ion concentration by reactant. At equilibrium, log Q is equal to log K. Therefore, using the Nernst equation, E cell is equal to standard cell potential minus 2.03 by into RT by F is equal to 0.059 by N into log product by reactant. Using this log product by reactant concentration is equal to log K. Therefore, if I know the K value, if I know standard cell potential, I can find the cell potential. In these three, any two are known, third one can be known. That is a standard question. Also, I have shown you that for in single electrode, sir, it's like anything that has positive charge. Zinc is a loser of electron. So it is the other left side electrode. Sometimes, hydrogen is the electrode that loses electron. Any metal ion loses electron. Whomsoever loses electrons, for a single electrode potential of the electron loser is always given by E is equal to E0 plus 0.059 by N into log concentration of the metal ion. For loser, always you have to put plus sign. Loser means in our Daniel cell, zinc is the loser of electron. It's in many cells containing hydrogen electrode and copper, hydrogen is the loser electron. So anybody is losing electron, that electrode potential under any condition of concentration is given by E is equal to E0 plus 0.059 by N into log C. C is the concentration. Sir, if you are taking a hydrogen electrode, standard hydrogen electrode potential is 0. Suppose you want to change the concentration H plus from 1 molar to 0.1 molar. Now, what is the electrode potential of She if the concentration of hydrogen ion became 0.1 molar? E is equal to 0, standard hydrogen electrode potential is 0, plus 0.059 by N. For hydrogen, H plus is gaining only 1 electron. Is it not so? N is equal to 1 into log concentration of H plus. What is the concentration of H plus? You said 0.1 molar. Then E is equal to E0 plus 0.059 by 1 into log 10 to the power minus 1. Sir, 10 to the power minus 1 means it will become log 10 to the power minus 1 will become minus 1. Therefore, what is the electrode potential of hydrogen when concentration of H plus is 0.1 molar means E is equal to 0 plus 0.059 by 1 into minus 1. It is minus 0.05 volts. Here is a shortcut formula. For any hydrogen electrode, I will write here. If 10 to the power minus 1 molar H plus ion means it is said to have a pH 1. If pH is equal to 1, then for hydrogen electrode potential is equal to minus of 0.059 into pH. That is a shortcut formula. Always the hydrogen electrode potential changes with pH. Hydrogen electrode potential is equal to minus of 0.059 into pH. This is a previous IIT question. When the pH of an electrode of hydrogen is equal to 10, what is the hydrogen electrode potential? Answer is minus of 0.059 into 10.59. For any electrode, if I change the concentration of ions, the electrode potentials change. If the electrode is electron loser, the change in the electrode potential is given by Nernst equation as E is equal to E0 plus 0.059 by N into log C for a loser of electrons. For a gainer of electron, if A is gaining electron, then the Nernst equation will become E is equal to E0 minus of 0.059 by N into log A. Because A is gaining electron, getting minus charge, you have to remember for electron gainers in the Nernst equation, E is equal to E0 minus 0.059 by N into log A minus concentration. For electron loser, by losing it gets plus charge. You will remember like that. For hydrogen, when it is losing electron, again it gets plus charge. Therefore, for loser, Nernst equation says E is equal to E0 plus 0.059 by N into log Mn plus. So for losers and metals and hydrogen, put plus sign, log of concentration. For gainers, put a minus sign, log A minus. That is the variation Nernst equation, easy way to remember. This is a previous IIT question, so I wanted you to remember it. Is that fine with you, sir? Are you clean, sir? Now we are going to look at next idea. What is the use of Nernst equation? Nernst equation is used to find the electrode potentials of cells under different conditions of concentration, temperature, pressure. Also, the Nernst equation is useful to know equilibrium constant, that is log K value and K value. Also, from some salts like AgCl, Nernst equation can be used to know the solubility product. So there are three important uses of Nernst equation. What is the Nernst equation? Equation that relates cell potential with the standard cell potential. NCERT talks very less about it. Okay, sir? I want you to read NCERT thoroughly. We are opening the NCERT book right now. Electrolytic cells have been discussed. The amount of material released during electrolysis is given by Faraday's first law and Faraday's second law. According to first law, M is equal to ZIT by ZD is the, of course, the electrochemical equivalent, sometimes represented by E. I is equal to current strength in amperes. T is equal to time in seconds. The electrochemical equivalent has a unit like grams per coulomb. In the NCERT book, they gave all the relations. Okay. According to second law of Faraday, when the same charge is passed through different electrolytes, the M1 by M2 is equal to E1 by E2, where capital E1, capital E2 represent chemical equivalent weight of those elements produced. The equivalent weight of magnesium, when it is gaining 2 electrons to become magnesium from Mg plus 2, is equal to atomic weight by 2. The equivalent weight of aluminum, when Al plus 3 is gaining 3 electrons to become aluminum, is atomic weight by 3. For the passage of 1 Faraday charge through any electrolyte, you get only one equivalent weight of the element. There is a standard problem 3.10 you can see. Here my main interest is to talk to you about the product of electrolysis. The product of electrolysis depends on two things. What is the nature of electrolyte? In the electrolyte, what type of ions are available? Secondly, what is the nature of electron? Thirdly, what is the concentration of electrolyte? First thing, nature of ions. Whenever you are passing electric current, there is a negative terminal, there is a positive terminal. The negative ions, anions, will always go to positive terminal, anions go to anode. The positive ions, that is cations, always go to negative electrode, cations go to cathode. Therefore, cathode is negative terminal, anode is positive terminal in electrolytic process. In the electrolyte, if I have water and sodium ions, for example, the sodium ions reduction potential is very less. Water reduction potential is high. So a fellow with high reduction potential is reduced first. Therefore, water will get reduced to become hydrogen gas and OH minus ions. Na plus cannot gain electrons to become sodium because the electrode potential of sodium is negative. Therefore, whenever there is a competition between two ions to gain electrons, fellow with a high reduction potential is reduced first. Often the first group metal ions and water, if there is a competition, water gains electrons. If there is a competition between chloride ion and water to gain electrons, to lose electrons, the fellow with low reduction potential is oxidized first. Between chloride ions and water, it appears water has low reduction potential, so water should lose electrons first. But unfortunately, when water is undergoing the oxidation to give oxygen, the oxygen generation demands sometimes high voltage. It is called oxygen over voltage. Due to this problem of oxygen over voltage, though the water reduction potential is relatively less, water is not oxidized. It is the chloride ion that is oxidized. Here the problem is called oxygen over voltage. So during the electrolysis of salt water, the Na plus ions remain unaffected. Water undergo reduction to give hydrogen gas. The chloride ions undergo oxidation at anode to give chlorine gas. So at the end of the reaction, when NaCl in aqueous solution is electrolyzed, Na plus remain unaffected. Water will gain electrons to become H2 and OH minus. Therefore, the OH minus ions and the Na plus ions combine to give NaOH caustic soda. Thus, the electrolysis of salt water always gives caustic soda. Electrolysis of salt water is a method to produce NaOH. The typical cell which makes NaOH is called Nelson cell. This is a point I wanted you to learn thoroughly. And also we discussed about the sulfate ion. When the sulfate ion concentration is less, water will undergo oxidation to give oxygen. When the sulfate ion concentration is more, in a concentrated sulfuric acid, you will be getting sulfate ion undergoing oxidation to give S2O8. So this is a comparison I wanted you to remember. We have seen Nernst equation. I'm checking up for Nernst equation where it is. Just I talk a little about Nernst equation. This what we take up tomorrow. Conductance and all. We see all these ideas tomorrow. Tomorrow lesson will be very important. Nobody should miss tomorrow class. Tomorrow is very, very important. That is the essential part of electrochemistry. That is related to physics too. So nobody should miss tomorrow's class. Today class, people are telling me they are tired and therefore I don't want to torture them much today. Today I will leave you, but tomorrow class is very, 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 very important. Ladies and gentlemen, I have shown you that delta G is equal to minus energy. Okay, sir? Delta G is Gibbs energy function. Also, I said the Nernst equation can be used to find the what? Equilibrium constant. Calculate the equilibrium constant for the reaction. Copper plus 2Ag plus gives copper plus 2 plus 2Ag. Standard cell potential is equal to 0.46. Sir, I have suggested you one important relation. What is the relationship we have seen, sir? Yes, sir. You have seen that E cell is equal to E0 cell minus RT by NF into log product ion by reactant ion. That is the relationship. In other words, Nernst equation can be written for any reaction A plus B gives rise to CC plus DD as E cell is equal to standard cell minus of RT by NF into log product ion concentration by reactant ion. This is the general format. Now, sir, when the reaction is in equilibrium, the speed with which AB combined to give CD is equal to speed with CD combined to give AB back. At equilibrium state, what happens is, what happens, sir? At equilibrium, Gibbs free energy change, delta G becomes 0. Do you remember delta G is 0 at a equilibrium state? Hello, sir. Delta G is equal to 0 at equilibrium. Delta G is equal to negative for a reaction that happens by itself. Delta G is equal to positive for a non-spontaneous reaction. Delta G is said to be useful energy in a process. We remember useful energy in a process is equal to total energy released minus energy wasted. In a system, when it is in equilibrium, delta G becomes 0. When the equilibrium state is achieved, your battery will not work, it is dead. As long as the zinc is losing electrons, copper is gaining electrons, the cell operates. When the speed of the forward reaction is equal to speed of the backward reaction, then the cell is said to be dead. Always cell is said to be dead when it is not giving you any current. Please remember that when there is an equilibrium, cell is dead. When cell is dead, E cell is equal to 0. E cell can be equal to 0, but standard cell potential is never equal to 0. Therefore, when E cell is equal to 0, standard cell potential will be equal to RT by NF ln Q. So let us see the next relation that's very important. When the cell is dead, what is the important relation, sir? E cell is equal to 0, then E0 cell will be equal to 2.303 RT by NF into log product ions by reactant or log K. Therefore, sir, always this is a valid relation. Standard cell potential is equal to 0.059 by N into log Kc. Okay, sir? From this, you can infer that log Kc is equal to E0 cell into N by 0.059. Therefore, if you know the standard cell potential, you can always calculate the equilibrium constant. This is a very important application. But one application that is not given in the NCERT book immediately, that what we will work out, I want to tell on the board. For God's sake, now I want to unmute you. Can I unmute you? If anybody wants, they can unmute. I have facilitated you to unmute. Hello.
Yes, sir.
Now I think the fellow who is creating nuisance might have gone. Has he gone?
Yeah, he's gone, sir.
Congratulate him. So, ladies and gentlemen, I have an important message, sir. This I want to write very slowly, very carefully, because this is a question I am expecting. Sir, the cell potential is equal to E0 cell minus of 0.059 by N into log of equilibrium constant. Equilibrium constant means in a cell, when zinc is reacting with copper plus 2, you are getting copper plus Zn plus 2. When the cell is dead, the speed of forward reaction will be equal to speed of backward reaction. When the cell is dead, E cell is equal to 0. Therefore, when the cell is dead, E0 cell is equal to 0.059 by N here is equal to 2 log K. So what is the value of equilibrium constant for this cell, sir? E0 cell is 1.1 volts is equal to 0.059 by 2 into log K. Sir, what is log K equal to? Can you simplify it, sir? Hello. 2.2 by 0.059, how much, sir? Hello, use a calculator and tell me the value.
37.28.
How much, sir?
37.28.
Sir, if log k is equal to 37, k is equal to 10 to the power 37. If log k is equal to 1.3010, 0.3010 anti-log is equal to 2 into 10 to the power 1. K is equal to 20. Sir, if log k is equal to 2.6990, then k is equal to anti-log of 0.69905 into 10 to the power 2. That's true. Sir, if log k is equal to, say, 13.6021, anti-log of 0.6021 is 4 into this characteristic will become 10 to the power 13. Are we very clear about it, sir? Hello?
Yes, sir.
Yes, sir.
So if I know log k value, I can find the k value. The greater is k value, the greater is the extent the cell goes with forward reaction. Okay, sir? So the last equation can be used to find out the cell potential. That is one important point. Next most important IIT advanced and main question. Sir, this is very, very important, sir. I want you to pay your full attention. If you can't pay your full attention, tomorrow I will do. Because this is an expected question from this topic. Are you ready to take this important concept right now, sir?
Yes, sir.
Yes,
Thank
sir.
you.
We'll do tomorrow,
Thank you.
sir.
Sir, we have
You want me to?
prepare.
Because students are reporting me, sir, we are very much tired, sir. Today there is
We'll
no
do tomorrow, sir.
Sir, my students are reporting me over phone calls. Sir, today we are very much tired. Today physics paper is having 5 questions which are very difficult to type. In mathematics, 3 problems we understood but we can't solve them. Only chemistry paper is easy or average. Is it so? Hello?
No, sir. Chemistry paper average.
Which is average?
All 3 are average, sir.
I don't know. Some students are telling today we are tired. Are you tired today?
Max was somewhat tough, sir.
I don't know. So I'm hesitating to tell you, but I give you an idea. Very quickly, I give you idea to close the class. Sir, please look here, sir. Iron plus 3 is becoming iron, sir. Gaining 3 electrons. It is happening in one step. What is the iron potential when plus 3 is becoming plus? Suppose it is X. Now, iron plus 3 is gaining only 1 electron to become iron plus 2. Now, Y is equal to electrode potential corresponding to this. The third possibility, iron plus 2 is gaining 2 electrons to become iron. Now, the Z is equal to E0 Fe plus 2 by Fe. It means iron plus 3 can gain all the 3 electrons in one step, or iron plus 3 can gain 1 electron in one step. Again, it can gain 2 electrons in second step. Now, what is the relation between X, Y, and Z, sir? Yes. What is the relation between X, Y, and Z? X is equal to E0 Fe plus 3 by Fe, one step. It is E0 Fe plus 2 by Fe, Fe plus 3 by plus 2. It is E0 Fe plus 2 by Fe. Yep. What is the relationship, sir? You just simply cannot say X is equal to Y plus Z. It is like a problem of heroine. A particular cinema heroine, after acting for so many years, when she touched the age of 29, she thought that she should retire from cinema action because 29 years is a very big age. Therefore, she wanted to marry a nice gentleman who is very rich, whose age is 30. Is that fine to you, sir? She is looking 3 features. The boy should be handsome. Second feature, the boy should be rich. The third feature is the boy should be a good person. Now, she is not able to get one 30 years boy, but she could find 2 15 years boys. Because 15 plus 15 is equal to 30, can she marry these 2 boys?
No.
No, sir.
Or 6 5 years boys?
No.
Because
No,
they are
sir.
all handsome, they are all rich, they are all good also. Unfortunately, it cannot be an additive property. Another example, you are going in a train from Hyderabad to New Delhi. In the center, you are getting a station called Jhansi. Now, directly you buy one ticket to New Delhi that costs you about 2,500. Now, my question is, if I buy two tickets, one ticket and second ticket, if I buy a direct ticket, do you think that x plus y is equal to z? Or x plus y is not equal to z? What is fact?
Not equal to Z, sir.
In fact, x plus y, if you go, it will be like 3,500.
Yes, sir. Costly.
It is called a telescopic fare. If you are buying a ticket from Hyderabad to Jammu Tawi, the ticket cost will be 2,800. But if you go up to New Delhi, from New Delhi, if you buy a ticket to Jammu Tawi, it will be 1,200. It means 2,500 plus 1,200, 3,700. My God. Directly, if you buy, how much the ticket cost?
2008.
2000.
It means in telescopic rates, you are saving money. So if you want to travel across the India, you better buy a direct ticket and make break journey. Are we clear about this idea, sir?
Yes, sir.
Yes.
But if you are looking at the distance between Hyderabad and Delhi, and if Jhansi is there in between, distance between Hyderabad and Delhi is equal to distance between Hyderabad and Jhansi plus Jhansi and Delhi. Distance is an additive property. Some properties are additive properties, some properties are not additive properties. The electrode potentials are not additive properties. It is not equal to E0 Fe plus 3 by Fe plus 2 plus E0 Fe plus 2 by Fe. It is not additive. But delta G is additive. So, this corresponds to a delta G given by minus NFE1. It corresponds to minus NFE2. It corresponds to minus NFE3. Notice delta G is additive. So I cannot take E0 as such, but I can convert into delta G and say it is additive. In this case, N value is 3. F is 96,500. I know what is the E1. In this case, N value is 1. F is constant. E2 value they give. In this case, N value is 2. Ladies and gentlemen, therefore, using this, I can find out if I know E1 and E2, I can find out E3. Or in this 3, if I know any two, third one, I can find. Is that fine with you, sir?
Yes, sir.
Yes, sir.
Yes, sir.
That is a standard IIT mains problem. Okay?
Okay.
So, tomorrow we will be seeing variety of problems based on this. Also, for advanced, we need to learn about how to work out the solubility product using the electrode potentials. To know that, first I should know what is solubility product. To know solubility product, I should have a fair idea of a topic called ionic equilibrium in 11th class. Have you learned that lesson thoroughly, sir?
Yes, sir.
Then we will be looking at some problems based on that for advanced problems. Now, at the moment, this is an idea about how to work out the delta G. There are problems in the material I have shared. You can see the material and try to solve some. For ionic equilibrium, we will be giving a very brief revision in 5 minutes time to come today.
Okay, sir.
Ladies and gentlemen, if I am putting CaCl2 in water, CaCl2 in aqueous solution urgently dissociate into Ca plus 2 ions and 2 chloride ions. If I am putting sodium chloride in water, urgently it will break down to give Na plus and Cl minus. So in a glass of water, I put some salt, it will dissolve, it will dissociate. I put more salt, it will dissolve, it will dissociate. If I put a lot of salt, will it dissolve? Will it dissolve? Answer is definitely it will dissolve. Na plus Cl minus aqueous will form, but after some point, as much it is dissolving, as much is getting precipitated.
Yes,
The
sir.
speed of dissociation becomes equal to the speed of association. That state is called a state of saturation. The solution is called saturated solution. In a saturated solution, rate of dissolution is equal to rate of precipitation. Are we clear?
Yes, sir.
Yes, sir.
Now what happens is, if I am putting AgCl in water, if I put 1 mole of AgCl in water, when 0.00001 mole of Ag plus ion entered as aqueous ion, 0.00001 mole of Cl minus enters as aqueous ion, then the solution will become saturated. Urgently, any more dissolution amounts to backward reaction. It means AgCl is very, very less soluble. Very slight resolution makes the solution saturated. Therefore, you feel it is not dissolving. In fact, it is very less soluble. I call it as sparingly soluble salt. Ordinary salt dissolves nicely, a lot of amount dissolves. To get the equilibrium and precipitation, you need to try to dissolve more salt. For AgCl, very slight amount itself can make it precipitated. If I am putting barium sulfate in water, you feel it is not dissolving. Why it is not dissolving? Because its solubility is very, 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 very less. The salts whose solubilities are very, very less are called sparingly soluble salts. For a sparingly soluble salt, if I look at the concentration of the produced ions at equilibrium, what is the equilibrium constant for a reaction A plus B aqueous gives rise to C plus D? Equilibrium constant is given by concentration of C into concentration of D by concentration of A to concentration of B. The higher is the equilibrium constant, greater is the solubility or greater is the amount of product generally. Now what happens when CaCl2 is dissolving? At equilibrium, you will be having Ca plus ions and 2 Cl minus ions. So it's the ionic equilibrium constant is given by concentration of Ca plus 2 into concentration of chloride ion to the power 2 by CaCl2. The solid CaCl2 undissolved fellow, concentration is always taken as unity. So it is called Ca plus 2 into 2Cl into Cl minus whole square. This is called as solubility product. Solubility product is same as equilibrium constant. It will ignore the solid part. It will consider only ionic part.
Yes,
For
sir.
example, what is the solubility product of PbCl2? Solubility of PbCl2 is equal to Pb plus 2 concentration into chloride ion concentration to the power 2. For example, if I am saying 0.0001 mole of PbCl2 dissolves in water, in 1 liter water, what is its solubility product? Solubility product is equal to concentration of Pb plus 2 into concentration of chloride square. Now I have taken how much PbCl2? 0.001. For every 0.001 moles that dissolve, I will be getting 0.0001 moles of Pb plus 2 and 2 chloride ions. That is 2 into 0.0001 moles of chloride ion. Can we see it, sir? Hello?
Yes, sir.
Therefore, now the solubility product is equal to 10 to the power minus 4 due to the Pb plus 2, 2 into 10 to the power minus 4 whole square due to chloride ion. So it will be 4 into 10 to the power minus 12 mole cube per liter cube. Can you see it, sir? Hello?
Yes, sir.
Yes, sir.
Solubility product has a unit like mole cube per liter cube. Solubility product is 4 into 10 to the power minus 12 mole cube per liter cube, but its solubility is 10 to the power minus 4 moles per liter. So solubility is with respect to salt. Solubility product is with respect to the product of the concentration of ions as indicated by equilibrium constant. So solubility product and solubility both are different. If the solubility is less, solubility product will also be less, but they are not equal. Yes or no?
Yes, sir.
Yes, sir.
I can never judge which is more soluble by looking at solubility product. I can judge which is more soluble by looking at solubility. To avoid the confusion, here I have a problem. I would say solubility product of NaCl is 10 to the power minus 4. Okay, sir?
Yes, sir.
Yes.
Solubility product of CaCl2 is 10 to the power minus 6. Sir, 10 to the power minus 5. I will put like this. So now which salt is more soluble in water? Is it NaCl or is it CaCl2? Which is more soluble?
NaCl, sir.
I can never judge the solubility by looking at solubility product. I can judge the solubility by looking at the solubility value. Notice for NaCl, solubility product is concentration of Na plus into concentration of Cl minus, which is equal to 10 to the power minus 4. In this case, concentration of Na plus is equal to concentration of Cl minus because each NaCl gives 1 Na plus 1 Cl. So X square is equal to 10 to the power minus 4. X is equal to 10 to the power minus 2. So 0.01 moles per liter is solubility of NaCl. Let me look at for CaCl2. For CaCl2, they are saying solubility product is equal to 10 to the power minus 5. But its solubility product is Ca plus 2 into 2Cl minus whole square. So if it is X, it is 2X whole square into 10 to the power minus 5. 4x cube is equal to 10 to the power minus 5. X cube is equal to 1 by 4 into 10 to the power minus 5. X cube is equal to 0.25 into 10 to the power minus 5. Are you seeing it, sir? Hello?
Yes, sir.
Hello, sir. So x cube is equal to 2.5 into 10 to the power minus 6. So x is equal to how much, sir? Cube root of 2.5 into 10 to the power minus 2. Yes or no? Hello?
Yes,
Yes, sir.
Yes.
Sir, cube root of 2.5 is roughly, let us say, 1.1. So the solubility of CaCl2 is 1.1 into 10 to the power minus 2. And the solubility of NaCl is how much, sir? 10 to the power minus 2. Which is more soluble, sir? Hello?
CaCl.
CaCl.
So always the solubility product data is deceiving. You can never find out exact solubility of a salt simply by looking at solubility product. You should convert the solubility product into solubility, then you should make the judgment. This particular solubility product value is very much useful in the chemical industry. So to find the solubility product of many salts, often we use the cell potentials. How they are
Sir,
used,
once
we will see
in
the
previous
next
slide.
class. Hello?
Once previous slide, sir.
I don't know where that slide has gone, man. Is it this slide? Yep. This is the existing slide. No, that has gone, man. That has gone somewhere. That has gone. So anyway, today I gave you an idea what is solubility product. Tomorrow we continue on this idea. For today, I am closing the lecture because you need to take a break. You have so much time. Okay, God bless you. Meeting you. Be seeing you tomorrow.
Yes, sir.
Thank you.